Probability, combination, and permutation. When you multiply a sequence of numbers in descending order, like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, there is another, shorter way to write that, called factorial notation. You write the highest number and put an exclamation mark after it, like you're yelling out that number. So that long sequence of numbers just becomes 10, with an exclamation point after it. This type of notation is useful in a lot of mathematical situations, including probability. Oh, and if you ever see 0 factorial, it equals 1. That's just by definition. Don't question it. Factorial notation is useful for several reasons, but one really good one is in the calculation of combinations and permutations. Choosing a combination means you are selecting a certain number of things from a group and you don't care about the order in which you choose them. Choosing a permutation means you are selecting a certain number of things from a group and you do care about the order in which you choose them. So, for example, if I'm choosing 3 people from a group of 10 to win the same prize, the order in which they're chosen doesn't matter, because they all get the same reward whether they're chosen first, second, or third. On the other hand, if I'm choosing 3 people from a group of 10 to win first, second, and third place prizes, the order in which they're chosen does matter, because the rewards are different for first, second, and third place. The formula for calculating how many combinations you have looks like this and uses factorial notation. And the formula for calculating how many permutations you have looks like this. In the combination formula and the permutation formula, the C stands for combination and the P stands for permutation. Simple enough. The N stands for how many things you have in total, and the R stands for how many things you are choosing out of the total group. So, if I want to know how many ways I can give the same prize to 3 out of 10 people, that looks like this. 10 with a C in the middle and a 3 on the other side is equal to 10 factorial on top divided by 3 factorial times 10 minus 3 factorial. And if I want to know how many ways I can give first, second, and third prize to 3 out of 10 people, that looks like this. A 10 with a P in the middle and a 3 on the other side equal to 10 factorial divided by 10 minus 3 factorial. Easy enough. So let's work out the math. For solving these problems quickly, it helps to remember that larger factorial numbers include smaller ones. For example, 10 factorial is the same as 10 times 9 factorial, or 10 times 9 times 8 factorial, or 10 times 9 times 8 times 7 factorial, and so on. So let's apply that to a formula like this. Choosing 3 out of 10 in a combination, we've got 10 factorial on top divided by 3 factorial multiplied by 10 minus 3 factorial, or just 7 factorial. So we simplify it, and that's what it looks like. And since we know that 10 factorial includes 7 factorial, we can cancel out the 7 factorial, leaving us with this. When the 7 factorials are cancelled out, we've got 10 times 9 times 8 on the top, and 3 factorial on the bottom. So that's just 10 times 9 times 7 divided by 3 times 2 times 1, or 720 divided by 6, which is 120. So there are 120 possible ways to award the same prize to 3 out of 10 people. Or more simply, there are 120 ways to choose 3 out of 10 people when order doesn't matter. If order does matter, we just use the other formula. 10 with a P in the middle and a 3 on the right side. Or 10 factorial on top divided by 10 minus 3 factorial. Once again, 7 factorial cancels out on the top and bottom. That leaves us with 10 times 9 times 8, or 720, as our answer. That means there are 720 different ways to award first, second, and third prizes to a group of 10 people. Put another way, there are 720 ways to choose 3 out of 10 people when order does not matter.